Hey guys, today we're doing Chapter 3, Section 5, which is on the scale change theorem. So we've already talked about the graph translation theorem, which is when I'm translating a graph, moving it left to right, up and down. Now we're going to talk about the graph scale change theorem, which is basically I'm changing how narrow or wide a graph is by using multiplication instead of addition and subtraction. So a scale change centered at the origin with a horizontal scale factor a not equal to 0 and a vertical scale factor b not equal to 0 is a transformation that maps xy onto ax comma by. So essentially what I'm doing is I'm multiplying x by something and I'm multiplying y by something. If I want to find the image of the points below under a scale change of, if I'm going from xy to 3x2y, that means I'm going to multiply my x value by 3 and I'm going to multiply my y value by 2. So looking at this point here, if I plug that into my mapping, okay, I would take 3 times 2, and I would take 2 times 9 to get my new point here. So my new point would be 6, 18. Okay, I can do the same thing here. So looking at my mapping, this would be 3 times negative 3, and then 5 times 2. Okay, so this would become negative 9, 10. Okay, so doing the same type of thing, this next point here would be negative 12, negative 4. And this point here would be 3p, 2q. So let's consider the functions y1 equals x cubed minus 4x and y2 equals 3 times the quantity x cubed minus 4x. So basically what I'm doing is I'm multiplying this function by 3. I'm going to graph them on the window from negative 6 to 6 and negative 10 to 10. So going into my graphing calculator, I'm going to type in for my y1, I had x cubed minus 4x. And for my y2, I had 3 times the quantity x cubed minus 4x. Okay, now I'm going to go through and I'm going to change my window. So I'm going to go from negative 6 to 6 and then negative 10 to 10. I'm going to graph them. Okay, so my original function, my y1 graph first, so I know that's this kind of wider one going through the origin here. My translation image, or I'm sorry, my scale change image is going to be the taller one here. Okay, so what do you notice about the intercepts, maxima, and minima? So if I'm looking at the intercepts, I'm looking at where the lines are crossing the x-axis and the y-axis, and then the maxima and minima, I'm looking at these relative maxima and minima here. Well, what I notice is that the intercepts are the same. So the intercepts are overlapping, but the maxima and minima are different. Okay, so it looks like the intercepts are the same, and the maxima and minima have been changed by a scale factor of 3. If you look at the table of values in your calculator, what do you notice? Well, if I go to second graph and I look at this table here, I'll just go to 0. So I've got 0, 0, 0, 1, negative 3, negative 9, 2, 0, 0, 3, 15, 45, okay, 4, 48, 1, 44. So what you should notice is that if you take that y1 and you multiply it by 3, you're going to get your y2. So basically, if I go from y1 to y2, I'm multiplying by 3. So then it says, what is the transformation that maps y1 to y2? Well, if I'm multiplying by 3, and notice that that was just with my y values, the transformation for this function would be s of xy, I use s because it's a scale change, is equal to x 3y. So I haven't actually changed my x values, but I have changed my y values by a factor of 3. Now, I want to consider y3, which is this function here, the quantity x over 2 to the third minus 4 times the quantity x over 2. And I want to graph y1 and y3 on the same window. So I'm going to get rid of my y2. I'm just going to unhighlight it. Okay, and then in my y3, I'm going to type in this new function, which is x over 2 to the third minus 4 times x over 2. Okay, and I'm going to graph those on the same window. Okay, now I'm going to ask the same questions here. So, first thing, how are the x-intercepts, maxima, minima changing? Well, you should notice that the maxima and minima are staying the same in this case, and the intercepts are the ones that are changing now. So this intercept here is at 2, and this one's at, negative 2 and negative 4. This one's at 2 and 4, so they're actually doubling. So it says here, notice how the x-intercepts, maxima, and minima of y3 occur at x values twice that of y1. Okay, so the maxima and minima stay the same, and the intercepts change this time by a factor of 2. Okay, so what is the transformation that maps y1 onto y3? Well, in this case, we're changing our x values, so this is going to be s of xy equals 2xy. So I'm not changing my y value in this case, but I am doubling my x value. So this leads us to the graph scale change theorem, which is given any parent graph y equals f of x, we can say y equals b times f of x over a is its image under the vertical scale factor b and the horizontal scale factor a. Okay, so essentially, the graph scale change theorem is pretty much just like the graph translation theorem in the sense that you do the same process to actually find functions. So if I look at this function here, inside my function I was dividing my x by 2, which is why in my my scale change equation I multiplied x by 2. And over here, in this one, I was multiplying, if I were to rewrite this, this would be y2 over 3 equals x cubed minus 4x. So I'm dividing my y values by 3, which is why in my scale change equation, I'm multiplying my y values by 3. So it's the same thing that we were doing with the graph translation theorem, where between my translation and my actual equation, I'm doing the opposite things. So, one more thing is with negative scale factors, if you have a scale factor that's a negative number, that produces the combined effect of a scale factor of k followed by a reflection over the appropriate axis. So basically, if you're multiplying your x value by a negative number, remember in the last section we were talking about even and odd functions, so changing that x value would be like a reflection over the y-axis. If you change your y value, that's like a reflection over the x-axis. And if you change them both, that's like a rotation around the origin. So depending on where your negative is, that produces that sort of reflection or rotation as well as a scale factor. All right, and that is everything for section 5.